Hey everyone, welcome back. A new approach to car battery is about to transform the EV market, the EV industry. Now I got this article courtesy of The Wired. Auto companies are designing ways to build a car's fuel cell into frames, making electric rides cheaper, roomier, and able to hit range of 620 miles. That would be insane. That would be crazy. So I found this article and it actually seems rather interesting to break down into some of the details, some of the nuanced cases, and what it could mean to design electric vehicle batteries in a slightly different way that could be better off. Now it says here, one of the biggest banes for car designers and engineers, batteries are exceedingly heavy and dense. And with the internal combustion engine rapidly pulling over for an electric future, the question of how to deal with EV added battery mass is becoming all more important. So if you want to build an EV with better range, slapping in a larger battery to provide that range is not necessarily the solution. Well, that's interesting. So what manufacturers are doing, in my perspective, such as Tesla, they're using new methods to develop new battery cells that could potentially be more beneficiary. And this has actually given Tesla a evolutionary advancement, 5 to 10 year advancement in their vehicle design and development, in their battery work and development. Simply put, other manufacturers are not working at the same scale as Tesla. So Tesla is getting a huge leapfrog. So now that we understand the idea that simply putting a bigger car battery in the car isn't the best solution because these cars are heavy enough, you would then have to increase the size of the brakes to make them capable of stopping the heavier car. That's where it gets even crazier. And because of the bigger brakes, you would now need bigger wheels. And the weight of all of those items would require a stronger structure. This is what car designers call the weight spiral. And the problem with batteries is that they require you to lug around dead weight just to power the vehicle. That's crazy, right? Now, what if you could integrate the battery into the structure of the car so that the cells could serve the dual purpose of powering the vehicle and serving as its skeletons? Now, this is exactly what Tesla and Chinese companies such as BYD and CATL are working on. The new structural design coming out of these companies stand to not only change the way EVs are produced, but to increase the vehicle range while decreasing manufacturing costs. Now, according to Ewan Maturk, a consultant battery electrochemist at Plug Life Consulting, since technologies such as cells-to-pack, cells-to-body, and cells-to-chassis battery constructions allow batteries efficiently distributed inside the car, they give us much closer to a hypothetical perfect EV battery. The ultimate battery pack would be one that consists of 100% active material. That is, every part of the battery pack stores and releases energy. Now you see, in my opinion, I already thought that's what EV batteries were doing. I thought that 100% of the EV battery was there to store and to distribute that said energy. So let's try to understand why I'm wrong and why it's actually completely the other way around. Now, traditionally, EV batteries have used cell modules that are then interconnected into packs. Now, BYD pioneered cell-to-pack technology, which does away with the intermediate module stage and puts the cell directly into the pack. Now, according to Roshi Frost, the founder and CEO of Sprint Power, standard modules may fit well within one pack but leave large areas of waste space in another pack. Now, by removing the constraints of the module, the number of cells can be maximized within any enclosure. So cell-to-pack allows the module building blocks to be left out of a battery pack, meaning less waste volume. BYD also championed LFP, lithium iron phosphate, batteries which have better chemical stability and cheaper to produce. Now, one problem is that the energy density of the LFP cells isn't that good compared to the NCM. That's the nickel, cobalt, manganese. That's the nickel, cobalt, and manganese chemistry cells used in EVs like Hyundai Kona electric vehicle, Jaguar I-Pace, the Volkswagen ID range. However, cells-to-pack design enabled the company to fit more cells into a given space and to increase the density to a level closer to that achievable with the NCM batteries. Now, Shenzhen-based BYD is one of the world's most vertically integrated EV producer, simply meaning it makes the batteries, many of the electric components, and the car themselves, but it actually started out as a battery company. Its bigger rival is the Chinese battery space, its contemporary Amperex Technology, a company in that 2021 was the world's largest EV battery producer with a 32.6% market share. That's crazy. This was largely due to CATL dominating the Chinese market with a 52% market share. Now, CATL already has a plant in Germany, along with a $5 billion plant under construction in Indonesia and plans for a similar investment in the US. It owns investment in both lithium and cobalt mining that helps shield the company from monetary prices fluctuations. But one of the key factors of CATL's global expansion will be cells to chassis technology, where the battery, the chassis, and the underbody of the EV are integrated as one, completely eliminating the need for a separate battery pack in the electric vehicle. Now, redistributing the battery bulk will also free up space in the car design for a roomier interior, since designers will no longer need to raise the floor height of an EV to slash the cells underneath in a big slab. Freed from these previous constraints, the cells can make up the entire chassis. Manufacturers will be able to squeeze more cells into an EV, thereby increasing range. There you have it, ladies and gents, a different idea, a different way of building EVs. Now, CATL estimate that production vehicles of the design will achieve range of 1,000 kilometers. That's up to 621 miles per charge, a 40% increase over conventional battery packs. Now, this essentially, a car with over 500 miles of range essentially is the perfect EV vehicle. That's if they can manage to keep the cost low. But of course, as with everything, time will tell. So I hope you enjoy this article. I hope you enjoy this video. It's a really cool idea. It's a really cool concept that new companies, EV companies, electric vehicle companies, they're working on this technology because they believe that it could be the future. So what do you think? Do you think it could be the future? Leave a comment. Let's have a discussion. Thank you for watching. Subscribe to see more. And of course, I'll see you in our next video.